We are doing applications of sine and cosines. And I will come up with both sine and cosine because they are equivalent. However, sine is generally considered the standard you do, but I also have the cosine that we can do because they're not that far off. There's one slight difference. So here we have the information for the hours of daylight on the 15th of each month in New York, New York. It sounds nice, they named it twice. Calculate the sinusoidal model and use the model to estimate the number of hours of daylight on September 30th. So here's what we're dealing with. We have the information. We want to do a sine curve. Why do we want to use a sine curve for this? Because the hours of daylight fluctuate from year to year on a 12-month cycle, right? As we pass through a year, everything repeats itself pretty darn close. They may not be exactly the same full length on the longest day, may not be exactly the same shortest length on the shortest day, but they do. Hours of daylight fluctuate on a perfect sine curve, almost exactly. Okay, it's one of those things. It's the seasons. It's the way it does. It's the rotation around the sun. It's a perfect pattern. Now, here's what you want to do. First thing, change the months or put in front of the months numbers, because we're going to make it into a numerical thing. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we have a set of coordinates. 1, 9.5, 9.58, 2, blah, blah, and so on, right? We have a set of coordinates to work. To find a proper sine curve, we need to find a few things. The first one to find, the easiest one to find, is the amplitude. Okay, to calculate the amplitude, remember the amplitude is the difference between the highest and the lowest, right? Okay, so the amplitude is the maximum minus the minimum divided by 2, because it's not the full length. Remember, the amplitude is half. Standard amplitude is 1, but that goes from 1 to -1. So the length between the top and bottom maximum is 2. Our amplitude is half of that. So that's what you do. You find your maximum value and your minimum value. And our max is 15.7. Our minimum is 9.27. It is important that you identify where those are and where the months are, because when we do our phase shift, those will also come in handy. So you take 15.07 minus 9.27, divide that by 2, and you get an amplitude of 2.9. That's our amplitude. That's what's going to go in at the front of our equation. Tied with the amplitude is the phase shift. Okay? To find the phase shift, we have to find how much above and below, because we don't go from -1 to 1, right? And we don't go from -2.9 to +2.9, do we? We move up considerably from that. We don't have negative daylight hours. Our daylight hours are positive. They moved up. We don't go from -2.9 to +2.9, which is if our amplitude was just that. We have to do a vertical shift to go with it. Our vertical shift is actually very easy. You take the minimum value and add the amplitude, and that will tell you how far the whole thing moves up. Find the middle. Your vertical shift is where the middle value is. To find your vertical shift, you take the minimum value plus the amplitude. 9.27 plus 2.9, and you end up with 12.17. That's our vertical shift. The whole graph is going to shift up that much. And I'll show you the graph here after we get done doing it. You'll see what I'm talking about and how it lines up. Okay. We need to figure out our period. Okay. Our period, the normal period is 2 pi, right? Our period on this one is going to be 12, because it repeats every 12 months. Our period is 12. Does that make sense? Every 12 months, this cycle repeats itself. So our period is 12. So what we need to do is, our period is 12. Well, that's 2 pi divided by W. Remember, when we're trying to write the equation, we don't put 12 in. We put in whatever W is that adjusts 2 pi to 12. Okay? Swap it, cross multiply, whatever you need to do. This means we have pi over 6 as our period adjustments. Okay. Now, that's all pretty straightforward and easy to do. The phase shift, on the other hand, that's a pain in the butt. Okay, the phase shift, that's a pain in the butt. Okay. What you need to do for the phase shift is you've got to figure out how far over we need to make the adjustments to make it line up. So for the cosine, actually, it's pretty easy. The cosine is actually easier to find the phase shift on this one than it is for the sine. Because how does the cosine, when you graph the cosine, okay, when you graph a cosine, it starts the maximum value and then goes down. So if we go here and find the maximum value, instead of being at 0, where does our maximum value actually happen? It happens at 6. Instead of happening here at the beginning, our maximum value happens here at 6. So what do we need to do? We need to shift it over for the cosine. We need to shift it over 6. Okay, does that make sense? You have to go over halfway to get that. But the maximum value for the sine doesn't happen at the beginning. The maximum value for the sine happens 1/4 of the way through. So what we need to do is shift it to get to the maximum value, to have it start, instead of starting here, we have to have it start here. We need to have it start here to get us to the halfway point. For the sine, we have to start off on that one. Yes, it is more difficult to actually do the phase shift of the sine on this particular one. Cosine works easier because I take my maximum value, shift the whole graph over just that much. But here's the general rule: the phase shift for the sine and something like this is going to be half of what it is for the cosine. So for the cosine, my phase shift for the cosine is 6. For the sine, it's 3. Okay. Because normally the sine would have its maximum value here, but we need to shift it down to that point. So we need to move it 3 units. Because where does the maximum happen for the sine? It happens at pi over 2, 1/4 of the way through the period. Okay. So it shifts 1/4 of the way over. For the sine, it starts at 0 and goes up and then comes down. Well, that's pi over 2, which is 1/4 of the way through my cycle. So I need to take that maximum value and shift it over 1/4 rather than all the way over. So instead of going halfway over, it goes 1/4 of the way over. 3 months. Okay. So let's do our graphs, our equations. Y equals, what was our amplitude? 2.9. Times the cosine, and I'm going to do the cosine here. I'm also going to do the sine both. Okay, the cosine of what was the next thing we have was we have our period change, pi over 6. So we have pi over 6 times x. What was the phase shift on the cosine? 6. And we move it in the positive direction, so that means we want to subtract 6, because remember, it's always the opposite on the inside. Minus 6. Okay. You can distribute if you want. I'm not going to worry about distributing. And then what was our vertical shift? Plus 12.17. Move the whole graph up, 12.17. Okay. If we do it for the sine, everything's the same except for the phase shift. Y equals 2.9 sine of pi over 6, x minus 3 plus 12.17. And that's what the sine would look like. Because you only go halfway over. And there you go. So that is that graph. That's the sine. Cosine is exactly the same. By typing the cosine of the lay right on top of it. And I plotted the points. You can see how the points follow the curve. It does follow the curve. Does that make sense? Okay. Maximum, minimum line up. Your middle, your vertical shift lines you up right smack down the middle of those two values. You got to figure out the period. How long does it take to repeat itself? And from there, do I need to shift it over? How much? Okay. Does that make sense? Notice, like I said, how it lines up on the points. It looks, all right, is it exactly on the points? No, but it's pretty darn close. Close enough for anything we'd ever do. Okay. Questions on that? Okay, and there's another part to that question. What's the last part of the question? To estimate what the daylight is on September 30th. September 30th. So if I go to September, that's what? That's 1, 2, 3, 4, 5, 6, 7, 8, 9. But what date is this actually being measured on? On the 15th. What date do we actually want to know? The 30th. So are we going to plug in 9? No, we're going to plug in 9.5. Because 30 is 15 days. It's halfway through a month. Does that make sense? Because these get counted on the 15th. These do not count it on the 1st. These get counted on the 15th. So to find that middle one, to find the September, to find it for that date, or that particular, for that particular date, I got to figure out how many days past the 15th I'm counting. Well, that's 15 days, which is how much of a month? Approximately half a month. 15 days is about half a month. So what do? We let equal x equals 9.5. And you take either one of those two equations and plug in 9.5 for x. Y equals 2.9 sine of pi over 6, 9.5 minus 3, plus 12.17. And you stick that in your calculator and see what you get. You will for this portion. You will for this stuff. I'm not going to make you do this stuff. So I forgot to write it down on my notes. What did you get?
I'm still doing it.
You got 11.42? And I think that's, I have 11.42. Anybody else? 11.42? Okay, that seems to be the consensus. I'm good with that, 11.42. And if you look, it makes sense because that's halfway between these two. That seems about right. Should be about halfway between those two values, give or take. And it is. It's about halfway between those two values. So I predict on September 30th, at the end of September, you're going to have 11 3/4 hours of daylight, approximately, in New York, New York. It will not be the same somewhere else. Okay. Questions? This is nice. This is a good prediction. This is a good example of how this works. Okay. Average monthly temperatures in Juneau, Alaska are given. Determine the sinusoidal model for the periodic phenomenon. So please take a few minutes, try and see if you can figure out the different parts you need to make it work. Amplitude, vertical shift, period change, what the W is for the period. See if you can figure out the phase shift. See if you can come up with the equation. Do sine or cosine. Actually, you should be able to do both. You do not need to make a prediction on this one, because we're on our new schedule. Okay, so you are aware, I have them around the room. I wrote Mondays up here. I'm going to have the other days of the week up here for the rest of the week. But I do already have the new ones around the room. Although the remediation time is off by a minute each way because, and I did not know that when I made that up because they didn't tell me that until this morning. But that's okay. Okay, so our amplitude is the same thing. It's max minus min divided by 2. And when we do that, we end up getting for amplitude 21.9. Big amplitude. That's a pretty big amplitude. Cooper and Dominic. Okay, so there's our amplitude. Our vertical shift is still the minimum plus the amplitude, guys. Our vertical shift is still the minimum plus the amplitude. Our vertical shift ends up being 51.6.
Yeah.
Our period change is still the same because we're still 12 months. So W is still pi over 6. Same reason our period change is still the same period change. Doesn't make any difference. We already figured that one out exactly. Our phase shift is a little different on these ones.
Yes.
Because on the previous one, our maximum took place when? At 6. This one, our maximum takes place at 7. So instead of moving for the cosine, our phase shift for the cosine is 7, not 6. Because it moves the maximum 7 places. Okay? Which means the phase shift for the sine, instead of being 3, is now 4. Okay, normally, remember for the sine, the maximum value happens 1/4 of the way through the cycle. 1/4 of the way through the cycle would be here for the maximum. But we need to move it from here to there. We need to go from 3 to 7. How do you get from 3 to 7? You add 4. Because normally our maximum happens 1/4 of the way through for the sine. To move from 1/4 to where we're at 7, to go from 3 to 7, we have to add 4. Okay. So our cosine, y equals 21.9 cosine of pi over 6 x minus 7 plus 51.6. Our sine, y equals 21.9 sine of pi over 6 x minus 4 plus 51.6. And there we go. There's that one. Okay. Not a big deal, right? Fun, fun, fun. But you can see where it works and it matches up. This is what temperatures look like. This is what they cycle through. They cycle up and down as you go through the year. Same reasons that daylight cycles up and down as you go through the year. Orbit around the sun, tilting towards and away from the sun, and all the other crap that goes along with it. Climate change would do what to that?
Destroy increase.
Well, yeah, there's increase. Are we going to change the phase shift? Are we going to change the whole vertical shift? We're going to change the amplitude? Because remember, climate change is not just hotter hots, it's also colder colds. So we're getting a combination of those things that are taking place. So average temperatures overall are rising, so the whole thing's going to rise, but we also have some lower dips too, so it will change this, but it's still going to follow a sine curve. And how much we have changed from the sine curve from hundreds of years of data we've collected will show, hey, we got something going on here. Because if you take hundreds of years of data and you plot it out, it will follow really closely. With exceptions, obviously. But how much of those exceptions, and are those exceptions happening more and more often, that would just signify a change. See, math does work for proving things. Okay, this one, actually no calculator on this one, but you don't need it. Okay. We are taking a circular motion, a crankshaft, and converting it to a vertical motion. Piston moving up and down in its cylinder. We will not get into all the forces involved and torques and angles and all that crap. It really is much more of a physics problem. We're just doing the basics here. Okay? But that's really what happens. You've got a circular motion. That circular motion repeats itself. It causes a repeated vertical motion. It goes with it. Piston moving up and down, spring bouncing up and down. These are all perfect examples of sinusoidal motion. Something you can describe on a sine curve. So let's take a look at what's going on. First thing when I look at this, I notice one thing right off the bat that makes things so much easier. What's our period? Our period's 2 pi. How far does it go till it cycles all the way through? One full rotation of the circle gives me one full motion of the piston. So our period is 2 pi. No period change. Where do we begin? At 0. So for the sine, our midpoint takes place at 0. So if we use the sine equation, no phase shift either. So all we have to deal with is amplitude and vertical shift. So our amplitude is the distance, is halfway of the distance between the highest and the lowest point. What's the highest point? 7. What's our lowest point? 1. 1 is our lowest point. So it starts here, goes up, goes down, goes up. Our maximum is 7. Our minimum is 1. Our amplitude, 7 minus 1 divided by 2. Our amplitude is 3. Where's the midpoint at? 4. How do I get from how do I get from 1 to 4? I have 3, and it moves me up halfway. So our vertical shift is already given. Our vertical shift is already given. Normally, our vertical midpoint is where? 0, right? Our standard midpoint of a sine graph is 0. Where is the middle on this one? 4. So this is our midpoint right here. That is our vertical shift. We have a vertical shift of 4. y equals 3 times the sine of x plus 4. And I'm not doing a cosine for this one because I don't really need to, because this is perfect. This sine equation is perfect, and it's simple and sweet, and nothing else is being done to it.
You said period is 2 pi, right?
Yeah. And that's our standard period is 2 pi, so I don't need to put any adjustment for the period on there. That's no 2x, no half x, or anything like that. I don't have to worry about a phase shift because this one starts out at 0 just like the regular sine would. Now, is this the end of my question? No, where is it at 11 pi over 6? That means I take y equals 3 times the sine of 11 pi over 6 plus 4. 11 pi over 6 is negative 1/2. I'm just telling you because we're not out of time. But yeah, so it's negative 1/2 for that times 3. Negative 1.5 plus 4 means that we get 2.5.
2.5. I was gonna say 2.8.
Easy. Questions?